Okay. So we already discussed the first quadrant. That means electromagnetic torque and speed are in positive direction, so it will be act in the anti-clockwise direction, and load torque acting in the clockwise direction. Okay, so actual load motion of this load in the upward direction, acting in the upward direction, and the load torque acting in the downward direction. Okay, and in the second quadrant, that means torque acting in the negative direction, electromagnetic torque in the negative direction. So is shown here the electromagnetic torque acting in this direction. Again, motion is your in the upward direction. So angular speed, that means motion of this pulley acting in the anti-clockwise direction. Okay. So load torque acting in the opposite to the electromagnetic torque. So again, load torque showing here opposite, that means in the clockwise direction, opposite to the electromagnetic torque. Okay. So the motion of this imperative bucket in the upward direction. Okay. So the counterweight here in this shown in this bucket. That means you have to put some weight, so you can lift this empty cage in the upward direction. Okay, so in this quadrant, that means in the second quadrant, your electromagnetic torque acting in the clockwise direction, but speed act in the anti-clockwise direction. Okay. And just next in the third quadrant, what will be happening in the third quadrant? That means here the torque as well as the speed both are in opposite negative, so act in the clockwise direction. Okay, since electromagnetic torque and speed both are negative, so this will be act in the clockwise direction this way, and this empty bucket you want to put in the downward direction. That means since speed is your clockwise direction, so this will be go to the downward direction. Okay, and this is your counterweight, and load torque acting in the opposite direction to the electromagnetic torque. Okay, so you have to concern about this load direction, either electromagnetic torque and load torque. Okay, they are always act in the opposite direction. Okay, so first quadrant is known as the forward motoring mode. This one is known as the motor direction in the forward, but in the second quadrant, that means motor in braking mode, since a speed in anti-clockwise direction and torque developed in the clockwise direction. So motor will try to brake after some time. So that means speed in opposite direction and electromagnetic torque in and the speed are in opposite direction. So this quadrant is known as the forward motoring mode, forward braking mode. That means opposite in anti-clockwise direction, but electromagnetic torque start to act in the clockwise direction. Okay, so when the speed is positive and electromagnetic torque is act in the opposite direction, that is known as the forward braking mode. And in the third quadrant, that means electromagnetic torque as well as the speed are in the negative direction. So this mode of operation is known as the reverse motoring. Motor run in the reverse direction. Okay. And that means the actual direction of the motion of this imperative bucket in the downward direction, and load torque acting in the downward direction also. Okay, so this quadrant operation is known as the reverse motoring mode. Okay, and what will be about the reverse braking? That means direction of speed is same as the reverse motoring, but you have to develop the electromagnetic torque in the opposite direction to the motion. Okay, in the fourth quadrant. So the motion of the motor in the anti-clockwise direction, that means you maybe find out sorry, clockwise direction, that means negative speed, but develop the electromagnetic torque in the opposite to this motion. Okay, so electromagnetic torque developed in the anti-clockwise direction. Okay, so here you will find out electromagnetic torque and speed are in opposite direction. That means what, motion in one direction, but electromagnetic torque start in another direction. So that means we can say that we are applying the braking on the motor, but in the reverse braking mode. This is known as reverse braking mode. Okay, so you have to concern all these four quadrant operation. That means motor mode, forward motor mode, forward braking mode, and reverse motoring mode and reverse braking mode. So you have to keep their electromagnetic direction, development of torque and speed, and load torque active such direction. Okay. So here we discuss all the four quadrant operation, how we can act the speed and electromagnetic torque and load torque. Okay. In the first quadrant, that means both electromagnetic torque and speed are in same direction, as we seen from this quadrant. That means torque along the x-axis is also positive, and speed is also positive. So when we take the positive direction of electromagnetic torque and speed, that means conventional direction we consider in the anti-clockwise direction. Okay, so this quadrant is known as the forward motoring mode, where electromagnetic torque and angular speed are in the same direction, in the anti-clockwise direction, but load torque act in the hello, Ritesh,
Yes, sir.
just mute yourself or some voice coming from your side. Okay. Now it's okay. So here we are discussing the motor speed characteristic in different quadrant. That means in all the four quadrant, whatever the possible. Okay. So first quadrant operation is known as the forward motoring mode. In forward motoring mode, that means electromagnetic torque and the speed are both in anti-clockwise direction. That means both are in positive, and load torque are in opposite direction of the electromagnetic torque development. Yeah. But in the forward motor, that means we have to apply the braking on the motor. So we develop the electromagnetic torque in the motor in the opposite direction to the motion. Okay. So you will find out in the forward mode braking mode, that means direction of motion and development of electromagnetic torque are in opposite direction. So that's why we say that we are in forward braking mode. Okay. But in reverse motoring mode, that means both the electromagnetic torque and speed are acting in the clockwise direction, and load torque act in the opposite to the electromagnetic torque. That means both are here in negative. Okay. So you may find out here the direction of electromagnetic torque and load torque are act in the opposite direction. But since this is the motor mode in the reverse direction, so in the negative, that means this torque, electromagnetic torque developed in the motor and a speed are in the reverse direction of the first quadrant. Okay, so in the first quadrant, electromagnetic torque and speed are acting in the anti-clockwise direction. So opposite to that one, here act in the reverse motive mode in the opposite to that one. That means in the clockwise direction. Okay, so their movement of the imperative this bucket in the downward direction, since the speed of rotation of the motor or electromagnetic torque develop in the clockwise direction. So this load move to the downward, and load torque, that means this one is load torque act in the downward direction. This counterweight here attached for the movement, because this load will go to the upside since the electromagnetic torque acting in this direction. Okay, and in the fourth quadrant, we already say that the in this quadrant just we develop the electromagnetic torque in the opposite direction of the motion. So motion in this direction, so motion in the same direction, that means speed in negative, because it rotate in the clockwise direction. Okay, now we just develop the torque in the motor, that means electromagnetic torque in the opposite to this motion. So we can apply the brake on the motor, which motor is actually running in the reverse direction. Okay, so we just try to develop the electromagnetic torque in the opposite direction of the motion. So after some times, you maybe find out braking on the reverse act. Okay, so this is all four quadrant possible of the load movement with the help of motor. We can just drive either in the upward direction and in the downward direction. Suppose that the motion of the load and immediate load in the first quadrant in the upward direction, and in the first quadrant and second quadrant in the upward direction. But in reverse motoring mode or reverse braking mode, the motion in the downward direction, load and immediate load. Okay, so this type of requirement we maybe use in the industrial application purpose. You may find out some load lift in the forward mode in any particular instant. You may be applied put in the downward direction. So in that case, you may be seen their actual speed and electromagnetic torque development in the motor. Okay, and the direction of load torque. So this is all about the characteristic of the fourth quadrant. Now, just we want to next discuss the speed torque characteristic of DC shunt motor. Okay, so a speed torque characteristic of DC shunt motor, how we can control their speed, and what is the relation of DC shunt motor with the torque. Okay, that means with the torque. So this is the shunt motor connection diagram. That means with the help of 4-point starter we use here, or you may be used rheostatic starter method. Okay, either maybe or maybe used 3-point starter for start the DC shunt motor. Okay, so this is your 4-point starter. F represent for the field winding and A represent for the armature winding. Okay, with the external resistance that is represented here with the variable resistance connected through the armature. This one is your A armature of the shunt motor. Okay, and this is represent the field winding of the motor that is connected in shunt with the armature. Okay, so you will find out there current flow direction in the armature winding and in the shunt winding, shunt field winding. That means IA represent for the armature current and IF is your current flow through the field winding. Okay, so how we can just drive the relation of this speed with the torque development in the shunt motor. Okay, so do you know that what is the voltage equation we can write for this motor? Hmm? How we can write the voltage equation for this motor? Hmm? If we simply apply the KVL here, then we can write the voltage equation. That means you maybe say that back EMF induced in the armature coil of the motor, that is represented by EA. Okay, so this voltage may be considered as EA. So just apply the KVL in the circuit. So this is your V applied voltage to the motor. So V equal to how much? That means IARA, IAR, RA for the suffix, if you consider, that means the armature resistance, plus EB, that means back EMF induced in the motor. So voltage equation is your V equal to EB minus, EB plus IAR. R is your equivalent total resistance. That means nothing but R your static resistance plus armature resistance, that is represented by RA. Okay. So this is the voltage equation for the DC shunt motor. Now you maybe know that the torque equation in the DC machine. What is the torque equation? How we can write in the flux as well as in the terms of a speed, and back EMF equation. How much EMF induced in the DC machine? That is, you maybe know that these things. Okay, so just we try to find out their relation, is it not? Okay, so this is circuit diagram of the DC shunt motor, and we just want to drive their speed torque characteristic, how the speed and torque are related to each other. Okay, so you maybe drive their relation with the mathematical voltage equation. If you substitute the value of back EMF and torque, okay, then you are able to find out. So we just try to discuss these things or drive the derivation in the next class. So just we stop here, and in the next class we continue from this point, how we can drive the speed of this DC shunt motor related with the torque of motor. Okay. So this is the systematic diagram of the connection, how we can supply and start the DC shunt motor, and after that we just put the voltage equation. Voltage equation, if you put, then you will get that relationship. So we just try to see all these things in next class. Okay. So just we stop here, and in the next class we will continue. Okay.